Okay, welcome to factoring. Basically, the first most important thing to do is to check to see there's a GCF. Okay, you can watch the first recording about greatest common factor. That's your best choice when you first are looking at an expression or an equation that you're going to be asked to factor. Take out a GCF if there is one. It'll make your number smaller and make it easier to get the job done. Number two, you need to identify how you're going to factor. There are many types of factoring. There's several that we're going to learn this year. Some you've already learned. The first one we're going to call is the difference of two perfect squares. The difference of two perfect squares. So difference means it's going to be the subtraction, and then also two perfect squares. So the thing is, if you've got a binomial, look to see, are those two perfect squares that you are looking at. An example of this would be 25x squared minus 49. Okay, notice you've got two terms. It's subtraction between them, and A and B, both terms, are perfect squares. Well, how do you factor those? Well, factoring means break it up into items that when you find their product, go back to your original problem. And so, how do you factor these? Well, if you see there's a difference between two perfect squares, you take the square root of each, put one as a plus, and one as a minus. So that's a 7 there. Okay, so 5x plus 7 times 5x minus 7 should get you back to your original problem. And how do you know for sure if you've done it? Just like if you're saying the factors of 12 could be 2 times 6. Well, so if you find these two factors and you find their product, you would multiply them. Okay, FOIL this out. You get 25x squared minus 35x. And notice the product of these two would be positive 35x and then minus 49. Notice the middle two terms are opposites, and so therefore you do get back to your original problem. So if I say, okay, how do you factor this right here? Well, you'd say, well, look, there's two terms. They're both perfect squares, and so it's the difference of two perfect squares. So how do you factor it? The answer would be 5x plus 7 and 5x minus 7, and that would be your answer, because the product of those gets you back to your original problem. Here's another example here. If you have 75 x squared minus 27. Notice these guys right here are not the difference of two perfect squares. They are a difference, but they're not of two perfect squares. But look at it. If you take out a GCF of a 3, okay, so let's take out a GCF of a 3. You're left with 25x squared minus 9. Okay? Now, this binomial here is the difference of two perfect squares. So how would you factor it? Well, it'd be 5x minus 3 and 5x plus 3. Notice this time I wrote down 5x minus 3 and then 5x plus 3. The order doesn't matter. It's the commutative property of multiplication. As long as you take those two factors and you have their conjugates, 5x plus 3 and 5x minus 3, it doesn't matter which order you place those answers. And notice, if you check your work, you could FOIL out the middle term, or these two binomials. You get 25x squared minus 15x plus 15x, and then minus 9. Notice these go away, and you get 25x squared minus 9. And you could, when you distribute the 3 to each of these terms, you do get back to the original problem. So if I ask you to factor this right here, here is your answer. So the difference of two perfect squares is your first problem. Type of factoring, I mean, other than greatest common factor. Another thing that we've got is if there's a trinomial, okay? And so an example of trinomial factoring, again, if you can take out a perfect square, then you should do it, okay? And here's just a worksheet that I've had people do before. Okay, you can notice factoring with the difference of two perfect squares. Those are all examples of things that you could factor by the difference of two perfect squares. X plus 3 and x minus 3. Right here, 2x plus 9 and 2x minus 9. And this last one, it's not the difference of two perfect squares. If you take out a 3, you're left with 4x squared minus 25. Again, that's 2x plus 5 and 2x minus 5. Make sure you place the 3 there, because otherwise it won't equal your original problem. Those are the answers to each of these. Now, these next ones say factor the trinomial. Well, this one right here, factoring the trinomial, is going to go into two binomials. And this is kind of like the opposite of FOILing. What you need to do is you need to make sure that the product of the first two terms makes this first answer, and then you make sure that the product of the last two terms makes the last answer. That's not the whole thing, okay? That's part of it, okay? Because the deal is you could write x times x gives us x squared. Now the deal is that the product of bunches of things make 12. I mean 2 times 6, 3 times 4, 1 times 12, but you need to make sure when you FOIL out these binomials, when you double distribute or FOIL them, you get back to the original problem. So you can contemplate, am I going to put a 2 times 6 here? Okay, if you check this out, you get x squared plus 6x plus 2x and then plus 12. Although the x squared and the 12 are true, it doesn't really work for the 7, okay? And so we need to look to say, well, what do we need to do instead of that so that we could actually get the right answers? Let's erase this and start over fresh. So get rid of this. What could we put here for our second terms of each of these binomials that would give us the 7? Okay, and so we look at this, we say, well, let's try 3 and 4. Okay, so now if you FOIL this out, you get x squared plus 4x plus 3x and then plus 12. Notice that does equals x squared plus 7x plus 12. So that would be great. So the answer to this problem would be these two binomials, factoring that trinomial into those two binomials. And again, same for number 17. Okay, if you want to factor this, x times x gives us x squared, we need to find out what times what makes 40, but we can't ignore the negative 14. So we could play with those. We could say 4 times 10, we could do 2 times 20, we could do 1 times 40, but again, we have to make a negative. So think about your signs. How do you multiply to make a positive 40? Either two positives or two negatives. And it's apparent, looking at the sign here, that we really need to do two negatives. Okay, so again, we want to multiply to make a positive 40. How do you get a positive 40 with multiplication? Either two positives or two negatives. Let's use two negatives. And again, we want to make it a negative 14. And so making that wise choice is say, well, let's do 4 times 10. Okay, so when we FOIL this out, we do get x squared minus 4x minus 10x and then plus 40. It does check, so this is our problem. Now, let's look down to right here. We can talk about the AC box later on, and I think that might be some of how people learn this, either that or something called MARF. The deal is that you need to write down two binomials that will get you back up to here, if there are two binomials that will work. And so you can guess and check. Now, to make it to be 4x squared, you could do 2x and 2x to give us 4x squared. We could do 1x squared times 4x squared. There are multiple ways that you can get it, and it's basically working with your own brain to try to guess and check until you get to that answer. So let's try, just for fun, let's do 2x times 2x. The product of 2 times 2 gives us 4, and x times x makes x squared. Now, a lot of people, I had lots of grief last year where people said, well, Ms. Kinzer, I have issues because I know 1 times 5 or 5 times 1 gives us 5, but that won't give us 12. And they fought with me about it. And they said, how, you are wrong, there's no way we can do this. Well, let's just try 1 times 5, but let's remember this. Because this leading term is not just x squared, it's a 4x squared, we have these 2 and 2 here that are going to help us to reach our goal with the 12x squared. 12x is the middle term. So let's FOIL this out. So let's take this by each of these. So you get 4x squared, nice 4, and then plus 10x, and then plus 2x, and then plus 5. Notice when you add up these middle two terms, you get the 12x. This first is 5x squared, or 4x squared, I mean, and then that's 5 as well. So this indeed is the correct answer. Now, if you try something else and it doesn't work, then you get to keep trying until your two binomials work to make that problem. So let's try number 24. Okay, to make 3x squared, you've got 3x times x. Those are the only ways. Or you could do x times 3x. Okay, that's the only way. 3 times 1 makes 3, or 1 times 3 makes 3. And the thing is that order does matter because to make the 6, we got to make it a negative 6. There are a couple ways that you could make that happen. You could do 1 times 6 or 6 times 1. Because these are not exactly the same number, 1 times 6 is different from 6 times 1. We could do 2 times 3 or 3 times 2. But again, our goal is to make 7x. Okay, so let's try something, okay? And so if I say, let's try Just for fun, let's try 1 times 6. Okay, and again, we have to make this multiply to make a negative 6. So a product of a positive and negative make a negative. So you have to have one negative and one positive. So let's FOIL this out and see how good of or horrible of a job we did. FOIL this out, you get 3x squared, you get plus 18x minus 1x, and then minus 6. Not even remotely close to what we're looking for, is it? And so let's say, all right, well, we know that 3 times 1 is our only way to make this happen. So let's try a different way to make our 6 to work. So I'm going to erase this other stuff here. We're going to try this again. To make a 6, if it was just the sign that was wrong, maybe we would just reverse those two signs, but it's way more wrong than just the sign. So let's try 2 times 3. Again, negative 2 times positive 3 makes negative 6. That's not another option. So let's FOIL this out. So we go 3x times x is 3x squared. 3 times 3 is 9x. And that's minus 2x. Oh wait, this is going to be great. Minus 6. Notice 3x squared plus 7x minus 6 is going to give us our exact right answer. Again, if we had gotten the sum of these together and it had made the exact wrong sign, we wanted a positive 7x, instead of giving us the positive 7x, it gave us a negative 7x, we could try exchanging these two signs that make this a positive 2 and make that a negative 3 and see if that actually helped us better. But again, we're looking for two binomials that work to FOIL back to give us the original problem. Let's try another one. Let's put down two binomials. To make 2x squared, it's going to be 2x times x, or x times 2x. That's the only way you can happen. And then we've got to make a positive 3. Okay, 1 times 3 or 3 times 1. And yes, order does matter because we've got a number in front of this leading coefficient. And so let's check it out. Do we want to do 1 times 3 or 3 times 1? And your brain will start getting used to being able to think ahead. The middle term is created by the outer and the inner terms, the product of the outer terms and the inner terms, and either there's sum or difference depending if they're both positive or both negative, or one of each. And so to make a positive 3, let's try 1 times 3. And so if you can think about it, if we just put two positives together, positive 1 times 3 does make us give a 3, but we want to generate a negative 7 here. So a negative 1 times negative 3 does make a 3. And so we can work with this. Negative 1 times negative 3 makes a positive 3. We're looking also to make that to be a negative 7. Again, don't fight with me about 1 and 3 don't make 7. There are other things at play when we FOIL. We take 2x squared minus 6x minus 1x, and then plus 3. Notice this is exactly what we're looking for, so we accomplished what we wanted. If it didn't work, maybe try 3 times 1 instead of 1 times 3. The order matters when there is a term in front of your leading x squared term. Okay, let's try this one. We've got 2x and x. That's the only way to make 2x squared. We need to make 12. How are you going to make it to be 12? Well, we could try 1 times 12, 2 times 6, 3 times 4, and then also the opposite orders. We need to make it be a negative 12. So let's think about how are we going to be efficient to make a negative 12? Well, we need a positive and we need a negative. Okay, I don't know if we'll end up switching those signs or not. Let's make this to be a 5 in the middle, let's say. If this is a 6 and a 2, that'd be 12 minus 2. That's not going to work for us. Let's try a 4 and a 3. Okay? So if we do 4 times 3, let's check it out. We get 2x squared minus 6x plus 4x, and then a minus 12. That gives us a negative 2x for our middle term. That's not going to work. We've got 2x squared is great, and we've got minus 12. Let's try something else. Let's try, instead of 4 and 3, let's try 3 and 4. So we've got 2x squared, okay? The outer term is minus 8x, the inner term is plus 3x, and your last term is negative 12. Hey, look, it's perfect, okay? This is exactly right. It FOILs out to give us our exact right answer. So we have factored this perfectly. We have time, I think, for one more. If we can get it right. Let's try 6x squared. It could be 1 and 6, 6 and 1, 2 and 3, or 3 and 2. Let's try 3x and 2x. And for 1 and 5, let's think about how we're going to place this. We know we're going to need a positive and a negative. Let's try a positive and a negative, and let's see if we can make this happen. If we do a 5 here, we'll get 15 and 2. That doesn't seem like it'd work. Let's try a 5 and a 1. So the outer is going to be 3, and this is going to be 10. That might just work. Let's check it out. 6x squared minus 3x plus 10x and minus 5. It is so very